Medicine. I am Elizabeth Matthew with another video lesson on variation of conductivity and molar conductivity with the concentration. Before coming into today's topic, it is essential to recollect a few terms that we have learned in the previous classes. The terms resistance, conductance, resistivity, conductivity, all these terms have been discussing in our previous classes. So what is resistance R? Resistance is the obstruction to the flow of electric current, right? And this resistance R is directly proportional to the length of the object and it is inversely proportional to the area of cross section of the object. Okay, then that resistance R, we can write R is proportional to L divided by A, or so resistance R is proportional to L by A, or R is equal to a proportionality constant rho into L by A, right? Here this proportionality constant rho is known as specific resistance or resistivity. Okay, then what is conductivity? Conductivity is denoted by the symbol kappa, right? Then this kappa is the reciprocal of conductivity, is the reciprocal of resistivity. What is resistivity? Rho is resistivity. So conductivity is the reciprocal of resistivity. So we can write kappa is equal to 1 by rho. So rho is Ri divided by L. So 1 by rho is 1 by R into L by A. So what is 1 by R? 1 by R is the reciprocal of resistance, that is conductance. 1 by R is conductance. So kappa is equal to, conductance is denoted by the symbol G into L divided by A. Here L represents the length of the object and A represents area of cross section. If we consider the conductivity cell, the value of L by A is known as cell constant. What is the speciality of conductivity cell? Conductivity cell is used to find the conductance of solution. No? Then this conductivity cell consists of two platinum electrodes and are separated by a distance L and they have the area of cross section A. So for a particular conductivity cell, the value L by A is a constant. Okay, then if we fix the length between the electrode is unity, and if we fix the area of cross section of this is unity, then that means if L is 1 centimeter or 1 meter and if A is 1 centimeter square or 1 meter square, we can write kappa is equal to what? G. That means conductivity is equal to conductance when length between the conductivities, length of the conductivity cell is L, length between the platinum electrodes in the conductivity cell is 1 and the area of cross section is 1. So conductivity can be defined as the conductivity of a solution, conductivity of an electrolyte. It is the conductance of the solution, conductance of unit volume of a solution kept between two platinum electrodes separated by a distance unity and the area of cross section is also unity. So I repeat, conductivity of a solution is the conductance of unit volume of a solution. Conductance of unit volume of solution. Unit volume of solution means if length is equal to 1, area of cross section is equal to 1, length into area is volume. So if length is 1 and area of cross section is 1, then the volume of the solution will be unity. Okay, so conductivity is the conductance of unit, this is very important, conductance of unit volume of a solution kept between two platinum electrodes separated by a distance unity and the area of cross section is also taken as unity. Okay, that is the definition for conductivity. Then next let's come on to the term molar conductivity. Molar conductivity. Okay, so molar conductivity is denoted by the symbol lambda m. This is capital letter lambda and molar conductivity is denoted by the symbol lambda m. And let's take again, if from this equation we can write this is conductivity, this is conductance, or the conductance is equal to conductivity kappa into A by N. is not unity. Here, the length of the conductivity cell is taken as unity, and the area of cross-section is in such a way that the conductivity cell contains 1 mole of the electrolyte. Okay, that means if A is equal to 1 and A is not equal to 1 and G is equal to kappa into, if we multiply the term L with on numerator and denominator, we will get A into L divided by L into L. So A into L will be volume V and L into L will be 1. If we equate this equation into molar conductivity lambda M, if molar conductivity lambda M is conductivity kappa into A by L, then L is equal to, here also L remains same, L is 1, and the area of cross section, we can take this area of cross section, we can multiply it with L on numerator and the denominator. So kappa into A into L divided by L into L. Since L is unity, so L into L is definitely 1. So kappa into A into L, what is A into L? Length into area of cross section is definitely volume. So lambda M is equal to kappa into volume. Okay, so the term molar conductivity is defined as the conductivity of a solution containing 1 mole of the electrolyte kept between 2 platinum electrodes of length unity, and the area of cross section is A. Okay, when we consider the term conductivity, both L and the A are unity, and the conductivity is the conductance of unit volume of a solution. Okay, so molar conductivity is the conductance of volume V of solution. This is the conductance of volume V of solution containing 1 mole of electrolyte. Okay, I hope you have understood the difference between conductivity and molar conductivity. What is conductivity? Conductivity is the conductance of unit volume of a solution kept between 2 platinum electrodes separated by a distance 1, and the area of cross section is 1 square meter or 1 square centimeter. But molar conductivity is the conductivity of a solution containing conductivity of volume V of solution containing, here it was unit volume of a solution, but when we consider molar conductivity, it is the conductivity of volume V of the solution containing 1 mole of the electrolyte kept between 2 platinum electrodes of distance 1 unity, and the area of cross section will be A. Then next we have to discuss the variation of the term conductivity, variation of conductivity and molar conductivity with the concentration. Okay, then what happens and concentration increases, what happens to the value of conductivity? Since ions are the charge carriers, right? So if the number of ions present in the solution will be maximum, the conductivity value also maximum. Okay, so if we increase the concentration of the solution, or if the concentration of the solution is maximum, the conductivity value will be maximum. Why? Because if the concentration is high, means the number of ions present in unit volume will be high. If the number of ions high, the conductivity value also high. If we consider the strong electrolyte and also in the weak electrolyte, same happens. Okay, as concentration increases, the conductivity value increases. As concentration decreases, the conductivity value decreases. Because as concentration increases means what? Number of ions present in unit volume increases. Since ions are the charge carriers, current carriers, so the number of ions present in unit volume increases, conductivity value also increases. But when we consider molar conductivity, lambda M, the trend is reverse. Okay, here you just listen this equation. Lambda M is equal to conductivity into volume. From this equation, it is clear that volume increases, molar conductivity value increases. The volume and molar conductivity value, they are directly proportional. As volume increases, molar conductivity increases means what? Volume of a solution can be increased by adding more and more solvent, no? If we add more and more solvent to the solution, what happens? The concentration of the solution decreases. Right? If we add more and more volume to the solution, concentration of the solution decreases. That means as concentration of the solution decreases, molar conductivity value increases. Here concentration and molar conductivity value are inversely proportional. But when we consider conductivity value, as concentration increases, conductivity value also increases, because conductivity is the conductance of unit volume of a solution. Okay, so the concentration decreases means the number of ions per that unit volume decreases. So definitely concentration decreases, conductivity value decreases. But when we consider the term molar conductivity, what happens? The molar conductivity is directly proportional to volume. Okay, molar conductivity is the conductivity of volume V of a solution containing 1 mole of the electrolyte. If that 1 mole of the electrolyte is present in large volume, his molar conductivity value will be maximum. Okay, so molar conductivity value is the conductivity of the volume V of the solution containing 1 mole of the electrolyte kept between two platinum electrodes of unit distance, and they have an area of cross section large enough to accommodate that 1 mole of the electrolyte. Okay, so as volume increases, definitely what happens? Molar conductivity value increases. Volume increases means what? Concentration decreases. So concentration and molar conductivity values are inversely proportional. But the concentration and conductivity values are directly proportional. Okay, so if we increase the if we decrease the concentration of a solution by adding more and more solvent into it, definitely its molar conductivity value increases. So what will be the maximum value of this molar conductivity? If we add maximum amount of the solvent to the solution, okay, that we can say now this solution is at an infinite dilution. If the solution is at an infinite dilution or at a zero concentration, if the solution is in infinite dilution, we can say its concentration becomes zero. Okay, the solution is in infinite dilution or it at a zero concentration, the maximum value of this molar conductivity will obtain. Okay, that maximum value of this molar conductivity is known as limiting molar conductivity. Limiting molar conductivity. So what is limiting molar conductivity? Maximum value of molar conductivity or the molar conductivity value at the infinite dilution or at the zero concentration is known as limiting molar conductivity. As volume, as concentration decreases or if we increase the dilution, the molar conductivity value gradually increases. So at the maximum dilution or at a zero concentration, the molar conductivity value will be maximum. And that maximum value of molar conductivity is known as limiting molar conductivity, and it is denoted by the symbol lambda not m. Okay. Is it clear the difference between molar conductivity and limiting molar conductivity? Maximum value of molar conductivity is known as limiting molar conductivity. It is obtained at the infinite dilution or at the zero concentration of the solution. Clear? Then the variation of molar conductivity with the concentration, that is different for different electrolytes. That means it is different for strong electrolytes and weak electrolytes. Okay, when we consider a strong electrolyte, like what is the difference between the strong electrolyte and weak electrolyte? Strong electrolyte, when we put a strong electrolyte into a solvent, it completely dissociates. Or if you put a weak electrolyte in a solvent, the degree of dissociation will be less. It cannot dissociate into maximum ion. It cannot produce maximum number of ions from that compound. Okay, so when we consider the variation of the molar conductivity of a concentrated solution, for example, if we take sodium chloride, this is a very strong electrolyte. If we consider the variation of the molar conductivity value of strong electrolyte, what happens? It is found that, experimentally it is found that lambda m is equal to, lambda m is what? Molar conductivity value. Lambda n is equal to lambda 0m minus a into root c or a into c raised to 1 by 2. This is an experimentally observed, and this is the conclusion of an experiment. As a plus 2 student, you no need to go to the details of this equation. Okay. So lambda m is equal to lambda 0 m minus a into root c. But lambda m is the molar conductivity, lambda 0 m is the limiting molar conductivity, a is the constant, c is the concentration. Okay, and this constant, the value of this constant a depends upon the nature of the electrolyte. We can use different types of electrolyte. If we consider sodium chloride as electrolyte, the sodium chloride can produce Na plus ion and Cl minus ion. Okay, so the charge of the ion produced depends upon the the charge of the ion will be sodium of unit charge. Chloride ion is of unit charge. So this is an example of one electrolyte. If a particular electrolyte dissociates to form corresponding ions of unit charges, then that type of electrolyte is electrolyte. Okay, when we consider calcium chloride dissociates to form Ca2 plus ion and Cl minus ion. The cation will be Ca2 plus 2 unit positive charge. Anion will be Cl minus. So that is said 2-1 type electrolyte. So we can discuss 1-1 type electrolyte, 2-1 type electrolyte. What is 2-1 type electrolyte? Calcium chloride is the example. Calcium chloride can dissociate to produce Ca2 plus ion and Cl minus ion. Okay, if we consider magnesium sulfate ion, we can say that magnesium sulfate can dissociate to form Mg2 plus ion and SO4 2 minus ion. So this is a type of 2-2 electrolyte. Clear? So the value of A depends upon the nature of the electrolyte. That means the charges of the cation and anion produced from that electrolyte. Clear? So if a particular type of electrolyte, the value of A will be same. For all 1-1 type electrolyte, the value of A is a constant, is fixed. For all 2-2 type electrolyte, the value of A is fixed. For all 2-1 type electrolyte, that value will be constant. Okay, so this is similar to the equation of a straight line, right? Lambda m is y is equal to mx plus c. That is the equation of a straight line. Then, if we draw a graph between, lambda m versus c raised to 1 by 2. If you plot a graph between lambda m versus root c, if we consider the variation in the case of strong electrolyte, we will get a straight line like this. The variation, the decrease in molar conductivity value with increase in concentration. As concentration increases, molar conductivity value decreases. So this decrease will be a slow decrease if we consider the electrolyte is weak. If we consider the weak electrolyte, this decrease will be slow decrease. And the slope of this straight line, this is a straight line graph, and the slope of this straight line will be minus a. Y is equal to mx plus c. So slope of this straight line will be minus a, and its y-intercept will be what? Lambda 0 m. If we extrapolate this straight line and the point of intersection, we will get lambda 0 m, limiting molar conductivity. So it is very important to note, we will get the lambda 0 m value, limiting molar conductivity value of a strong electrolyte from a graph. Experimentally, in the case of strong electrolytes, experimentally we can calculate the value of lambda 0 m by extrapolating the graph. Okay, but when we consider a weak electrolyte like acetic acid, what is the speciality of a weak electrolyte? When we put a weak electrolyte into a particular solvent, the degree of dissociation is not maximum. It can produce a smaller number of ions into the solution. Okay, that type of electrolyte is known as weak electrolyte. And in the case of weak electrolyte, the degree of dissociation is very low at a concentrated solution. If we dilute the solution again and again, its degree of dissociation may increase. So, in the case of weak electrolyte, if we increase the dilution, or if we increase more and more solvent to that particular electrolyte, what happens? The degree of dissociation may increase. Due to this increase in the degree of dissociation, the limiting molar conductivity value will be maximum at lower concentration in the case of weak electrolyte. So, in the case of weak electrolyte, just a minute. So, in the case of weak electrolyte, what happens? If you draw the same graph, putting root C and limiting molar conductivity value. In the case, so if the electrolyte is weak electrolyte, we will get a graph like this. This is the variation of molar conductivity value with the concentration in the case of weak electrolyte. If it is a strong electrolyte, the graph was like this. Right? If it is a weak electrolyte, if the graph shape of the graph is not a straight line graph, the graph will be like this. Okay, so from this graph we cannot extrapolate this line to the y-axis, so we will not get the limiting molar conductivity value of a weak electrolyte from the graph. But we can get the molar conductivity value of a strong, limited molar conductivity value in the case of strong electrolyte from that graph. But in this case, we will not get the limiting molar conductivity value from this graph. Okay, so here if we decrease the concentration, the limiting molar conductivity value increases steeply. Why? Because the degree of dissociation increases at dilution. If dilution increases or at a lower concentration, if it is even though it is a weak electrolyte, it can dissociate maximum. Okay, so the limiting molar conductivity value increases. Clear? Then we will not get the limiting molar conductivity value from this graph. Then how will you find the limiting molar conductivity value in the case of weak electrolyte? In the case of weak electrolyte, we are using a special law for finding the limiting molar conductivity value. That law is known as Colroche law of independent migration of ion. That is Colroche law that we will see in our next class. For finding the limiting molar conductivity values of weak electrolytes, that value can be obtained by using a law. That law is known as Colroche law of independent migration of ions. Okay, we are not discussing that law in this class. We will discuss that later. Then one more important point is that here lambda m is equal to kappa into volume. No, if we increase the volume of the solution, increasing the volume of the solution means what? Decreasing the concentration of the solution. Okay, if we decrease the concentration of the solution, conductivity value also decreases, right? Conductivity value is directly proportional to concentration. If we decrease the concentration, conductivity value will decrease. But that decrease in the conductivity value will be compensated by the increase in volume. So the net result will be the increase in the molar conductivity value. Okay, so today we will discuss about what is conductivity, what is molar conductivity, how the conductivity value varies with the concentration, how the molar conductivity value varies with the concentration. Okay, we can summarize all these facts with a few sentences. What is conductivity? Conductivity is the reciprocal of resistivity, and conductivity is the conductance of unit volume of a solution kept between two platinum electrodes of unit length and unit area of cross section. Okay, whereas molar conductivity is the conductance of volume V of a solution containing 1 mole of the electrolyte kept between two platinum electrodes, and the area of cross section is large. Area of cross section will be A, not equal to 1. Then the conductivity value increases with increasing concentration, because the increasing concentration means the number of ions per unit volume increases. So the conductivity value increases with increasing concentration, whereas the conductivity value decreases with the decreasing concentration. Whereas in the case of molar conductivity value, the molar conductivity value increases with decreasing concentration and decreases with increasing concentration. Okay, then in the case of strong electrolytes and weak electrolyte, we saw the variation of molar conductivity value with the concentration. That is somewhat different. In the case of strong electrolyte, this variation is very slow decrease. This molar conductivity value decrease will be slow. Whereas in the case of weak electrolyte, if the concentration is very low, it will increase steep value. The value of limiting molar conductivity will be maximum at a very low concentration. Okay, so that's all about today's topic. Thank you very much.